Welcome to today's deep dive. Imagine trying to play a massive game of tin can telephone, but the string is over 150 feet long, and you absolutely cannot lose a single syllable of the message.
Right, and if you snag that string halfway through a wall, you basically destroy the whole thing.
Exactly, and that is the exact headache we are looking at today. We have a highly specific technical spec sheet from HDTV Supply, specifically for the DVIGear DVI-2340-AOC-M 50-meter cable.
What a mouthful,
Yeah,
yeah.
it is. But our mission today is extracting the hidden engineering marvels inside this thing. Okay, let's unpack this, because sending heavy digital video over 50 meters is no joke.
No, it's really not. I mean,
Right.
doing that over traditional copper wiring is fundamentally just at odds with physics. You're fighting massive signal degradation once you hit those distances.
Right, but this cable, which costs around $575, by the way, pushes up to 4.95 gigabits per second. Like, it is fully HDCP 1.4 compliant and supports single-link DVI resolution for up to 100 meters. So how are they avoiding that signal drop-off?
Well, what's fascinating here is the interior of the cable itself. It's actually a hybrid design. So they aren't just, brute forcing the data through a thicker gauge of copper.
Oh, so it's an optical cable, right, an AOC.
Exactly. It uses 4 polyfluorinated optical fibers running right alongside 6 standard copper wires. So it is literally transmitting the video payload via light.
Wait, but why keep the 6 copper wires at all? I mean, if light is so much more efficient for data, why not just go full optical?
Because of the division of labor. The fibers do the heavy lifting, right? They send the high bandwidth video via pulses of light, completely bypassing the electrical resistance that usually ruins long copper runs.
Makes total sense.
Yeah, but those 6 copper wires are crucial for the lower speed two-way communication. Like, they handle the HDCP copy protection handshakes, the EDI data, and they provide the required 5-volt power to run the active components at both ends.
Ah, okay, so the hybrid approach is perfect for the signal. But we should transition to the physical constraints, like actually installing this in a building. Because optical fiber is notoriously fragile.
Usually, yes.
Like, if I'm an installer pulling this $575 cable through a drop ceiling, and I know it's UL CMKOF plenum rated, so it's safe for airspaces, but aren't I terrified of snapping the glass core on a sharp corner?
Well, you would be if it were standard glass.
Yeah.
But remember those polyfluorinated optical fibers we mentioned? That is an advanced polymer, essentially plastic.
Oh, wow.
Because of that specific material choice, the cable boasts a minimum bend radius of just 2 millimeters.
2 millimeters. That defies logic. You could practically kink it around a pencil and the internal optics still line up perfectly to pass the light.
It completely changes how you can route infrastructure. And they've actually taken that physical flexibility a step further with the DVI docking connectors. They are fully detachable.
Here's where it gets really interesting. Anyone who has ever tried to fish a massive DVI connector block through a 1-inch conduit knows the panic of it getting wedged inside a wall.
Oh, it's an absolute nightmare.
Right, but here, you take off that bulky outer DVI head, and the cable's cross-section shrinks down to a tiny 13.9 by 14.2 millimeters. It's like taking off a bulky backpack so you can squeeze through a really narrow cave.
That's a great way to picture it. You're just pulling the slim internal housing, which perfectly protects those delicate optical pins. And we connect this to the bigger picture. They've engineered it with fixation screws and removable cable pull covers for added security.
Which is just brilliant practical engineering.
Totally. It directly solves the nightmare of riding cables through complex conduits. You secure the pull cover, drag the ultra-slim profile through, snap the DVI head back on, and screw it down. 0 signal loss, 0 broken cables.
So what does this all mean for you listening? I mean, whether it's for highly secure government facilities or massive sports bars, both huge markets for HDTV, Supply flawless video relies on this hybrid optical infrastructure. It completely marries digital speed with physical flexibility.
It really does make you look at the infrastructure hidden inside our walls a bit differently. I'll leave you with this. If commercial infrastructure relies on this hybrid technology to push massive data through a tiny 2-millimeter bend radius over 50 meters.
Yeah.
How long until residential homes completely abandon traditional copper wiring? How soon will our own homes run entirely on pure, zero-degradation light transmission?
I mean, it feels like it's right around the corner. Great question to end on.